Okay, part 2 of solving two-step problems, linear equations. Once again, I'm using the humongous book of algebra problems, of which I obtained copyright permission a long time ago. All right, so I'm just gonna go over some of the examples that they have here. It's just so it becomes like, it's like additional explanation. So what we have here is 3x equals 42. That's the problem they have in the book. And what we do is we divide both sides by 3 because we want to isolate the x, or we just want x, right? We want to say x equals something, not 3x equals something. So by dividing by 3, you're eliminating this, and this bugger here becomes 14. So x equals 14 because 42 divided by 3 equals 14. Next, problemo. All right. 10x equals 16. Now that's a bugger, but it's the same thing over and over again. We just want to isolate x. So we divide both sides by 10, right? Because 10x is really 10 times x. And to get rid of that 10, we would divide by 10, right? If you take 10 and you divide it by 10, you get 1. Or you take any number divided by the exact same number, you get 1. So we have x equals 16 over 10. That's the answer to that problem. However, mathematicians, being excessively fussy people, want us to reduce this to the lowest terms, right? They're always like busting our chops with that. So if you look at this 16 over 10, you can divide 16 by 2 and you can divide 10 by 2, right? And 16 divided by 2 equals 8, and 10 divided by 2 equals 5. Whoops, that's a very ugly 5. So x equals 8 over 5. All right. Okay, now we get into the killer problems. You guys ready for killer problems? Good. All right, so what we have here is 2 over 3 x equals 24. Now this is a killer. So if we're going, let's just take a look at this side, right? Because this is what we want. We want to get rid of this 2 over 3. So 2 over 3 times x. Let's just rewrite this problem so we can understand it. So if I divide by the same number, right? What is that really saying? Well, 2 over 3 times x times. Anytime you divide a fraction, you have to multiply it by its opposite, or inverse I should rather say, 3 over 2. Now let's look at this even closer. 2 over 3 times 3 over 2 times x. All I did was I stuck this guy here and I brought it here. You can do that in multiplication. You can change the order if it's only multiplication. Now, if you look at this problem, it's really 2 times 3 over 3 times 2 times x. Right? Because that's what multiplication is. You multiply the numerator and you multiply the denominator. So what you're really going to have is 2 times 3 equals 6 over 6 times x. And that's really saying 1 times x, which is really saying x. So here we divide by 2 over 3, and here we divide 2 over 3. And we do that because we want to get x. So x equals 24 divided by 2 over 3, or x equals 24 times 3 over 2, right? That's how you divide. You multiply by the reciprocal. So x equals 24 times 3 divided by 2. And the answer to that equals x equals 36. Now do the math by yourself. Well, I'll help you do it. 24 times 3, that's a 12. We add the 1, that's 72. Divided by 2, equals 36. And that's how you get that answer. Moving along. Another killer problem. 5 over x equals 2 over 7. So, let me just see, what are they saying here? All right. So what they're saying to do in the book is that in algebra, if you have two fractions, you can flip both and have a valid statement. So what they're saying here is that, let's do it without a fraction. Let's say I have 1 over 2 equals 6 over 12. Now that's a valid statement. All right, 1 over 2 does equal 6 over 12. If I flip both, 2 over 1 equals 12 over 6, it means the same thing, right? Because this is really 2, and this is 12 divided by 6, that equals 2 also. See what they're saying? You can flip. Now, here, we're going to do the same thing. X over 5 equals 7 over 2. We just did that. We just did the flipping thing. So now we have x divided by 5. What do we do? Well, I think if we multiply both sides by 5, 5x over 5 equals 35 over 2, right? X equals 35 over 2. And that's the answer. Let's do that. Do you guys want to do that one again? More slowly? Let's do it more slowly. Problem is, whoops, 5 over x equals 2 over 7. All right. So what they're saying here is that this is really messy to work with. It would be better if it were x over something, right? Because then you'd have to multiply both sides by 1 over 5, and it's just going to make a messy equation. But we can do it that way too. Here we have 5 over 5x equals 2 over 35. 1 over x equals 2 over 35. We have to flip to get the answer, right? So that's x over 1 equals 35 over 2. Anything divided by 1 is the number, right? So x divided by 1 equals x equals 35 over 2. See how we got the same answer? Let's do it again. Let's do the same problem. I do that often, especially when I'm learning. I do the same problem 10 times. 5 over x equals 2 over 7. We flip the two sides. You can only do it in this when you have a fraction equals a fraction. So x over 5 equals 7 over 2, right? I flipped here and I flipped there. Now I focus on this side. I want to get rid of this over 5. What do? I multiply everything by 5 here. I multiply everything by 5 here. I get 5x over 5 equals 35 over 2. I can eliminate these. X equals 35 over 2. So we see we got the answer. That was a tough one. That was a tough one. And I think we're ready to do problems. So what I'm going to do is do the problems. I'm going to go through every single one of them. Every single one of these problems I'm doing. And you can practice. And if I see that the problems are not covering enough the fractions, like this one here, number 30, number 33, number 40, I'm going to go over those ones really slow because those are the harder ones, and those are the ones that teachers never go slowly over. They're not very nice for that. So we'll figure it out together. All right. So let's do the problems next video.